In this video, we'll discuss informally the advantages of working with an augmented matrix over a system of linear equations. So, summarizing what we're trying to do, we want to start with a system of linear equations and solve it. We work on the system, modifying it step by step, and making it simpler and simpler until it's simple enough to solve. And we've seen the steps we're allowed to use, for example, multiplying an equation by a constant. We still don't know which steps to use when. That is, we haven't discussed how to actually do this, but we know the individual steps we're allowed to take. We've observed that each of these systems can be stored as an augmented matrix. And we've said that the process we're going to actually learn involves a detour rather than going straight down. We move around like this. We don't work with the systems at all, except in the first and last step, but instead use elementary row operations on a matrix, which are equivalent to doing these steps. But why? That is, if we could go from here down to here, why take this detour? There are a few ways we could answer this question, but I think what it fundamentally comes down to is that matrices are simple and equations aren't. Consider an equation. 2x minus y equals 7. It might not seem too complicated, but it involves two variables, x and y. Both those variables can take on an infinite number of values. And depending on those values, the equation can be true or false. Compare that to the augmented matrix 2, -1, 7. There are no variables. There are no infinite values that it can take on. It's just 3 fixed numbers. And it's just 3 numbers written next to each other. It is neither true nor false. In this video, we've tried to justify our decision to work with augmented matrices instead of systems of linear equations. We've argued that although an augmented matrix may be in some way equivalent to a system, they're used to store systems. They're in other ways fundamentally simpler than systems and easier to study. This is an idea that we'll come back to much later in the course when we discuss vector spaces.